exponential functions. Sketch the following graphs. Y equals to 2 to the x minus 1. Number B, y equals to 2 to the x then minus 1. So how do we tell that this is an exponential function? We can tell from the formula y equals to a times b to the x plus p plus q that this is an exponential function, given that it is given in this format. So from this format, for us to sketch the graph, we only need to know two things. One, the intercept. Two, the asymptotes. And the asymptotes for the exponential function y equals to q. That is the vertical, the horizontal asymptote. And we don't have the x asymptote. There's no way, there's no value you can put and make this equation not work. There's no value which you'll put and which you'll calculate and discover that the equation won't pass through that x point. So we only have one asymptote. This is like, unlike the hyperbolic function which has two asymptotes. In this case, we only have one asymptote. But this thing, it does affect the graph anyhow, but then it doesn't affect the asymptote of the vertical asymptote. We don't have it. We don't have the vertical asymptote. We only have the horizontal asymptote. And then number two, we get the intercept, as I said. So let's try the example A. Y equals to 2 to the x minus 1. And we're looking for the intercept. Let's look for the y-intercept. Y-int, this is x equals to 0. Y equals to 2 to the x minus 1. Then y equals to 2 to the 0 minus 1. From your calculator, this will be 2 to the negative 1. This equals to half, or 1 over 2. And then the coordinate is 0 and 1 over 2. And then the x-intercept, we only have the x-intercept in this case. Why? Because the asymptote, it is on the line. Why is this? I didn't write the asymptote. Okay, I didn't write the asymptote. The asymptote of this graph, let's say we were to say this equation is y 2 to the x minus 1. For us to get it clearly, let's say it was plus 0. If this is plus 0 like this here, we can clearly see this is 0 will be q. So our asymptote y equals to 0. This is the horizontal asymptote. Then if we were to draw the graph, this line here, the x-axis, this is where y equals to 0 at this point. So this is the horizontal asymptote. And then the coordinates 0 and 1 over 2. This is where it is. It is here. Then then if we were to sketch the graph, it will go like this. The values of x are increasing, or how can I say it? The values of y increases as the values of x increases. When x increases here, y also increases. And then when x decreases, this keeps on decreasing. When x decreases, y also decreases, but it never go to a point where you find y is 0 or it will decrease and decrease, but you never touch the x-axis. But then it also it also increases as they both increases. That's the reason why it looks like this. The proportionality. Y increases as x increases. This is why the shape is like that. Then for number B, y equals to 2 to the x minus 1. Let us find the asymptotes first. Remember, the question is we are asked to sketch the graph. Then for us to sketch, let's get the asymptote, which is only the horizontal asymptote. Y equals to negative 1. Okay. Then the intercept, y-intercept, this is where x is 0. Then y equals to 2 to the x minus 1. Y equals to 2 to the 0 minus 1. And then y 2 to the exponent of 0, that is 1 minus 1, y equals to 0. Then the coordinate is 0 and 0, and then the x-intercept, at this case we will have the x-intercept. Why? Because the asymptote is now below the x-axis, so the number between negative 1 going upward may be one of the intercept. Let's find it out. X-int, this is where y is 0, so we're looking for a point where y is 0 on the graph. Let's look where's that point. 2 to the x minus 1 and 0, 2 to the x minus 1. Add 1 both sides, you get 1 equals to 2 to the x, and then this is 2 to the 0 equals to 2 to the x. Oh, you change 1 to this format. We all know that 2 to the 0 equals to 1. Any number raised to exponent of 0, it will give you 1. And then at this point you revise your laws of exponents. Equating powers of the same base, you also equate the exponents. Therefore x equals to 0 or 0 equals to x. I just put it the other side. Then the coordinates is 0 and 0. So x-intercept and the y-intercept, they are all on the point 0. Okay, then if we were to sketch the graph, it will be like something like this, and then that intercept is here, the x and the y-intercept, and the negative 1, which is the this is x, this is y, horizontal asymptote. And then how is the graph going? Is it this way or this way? How do we tell by that? We look at the equation. If we were to put any number here, maybe let's say you put 1. Okay, if we were to put 0, you get 1 as y. Then if you put 1, you get 2 to the 1 3 minutes. That's the answer will be 1. If you put 2, 4 minus. So if you can notice, any value, if you increase the value of x, the value of y also increases. The more you increase the values of x, the more the y values increases. And as well, if the more you decrease the values of x, the values of y also decreases. Which therefore this also looks like the previous question. It goes this direction. Remember, decreases going to the left hand side and increases going to the right hand side. So this graph increasing. As the values of y increases, as the values of x increases, the values of y also increase. Remember, y depend on x. So as x increases, y also increases. For this specific question, not always on a exponential graph, but for this specific question, x increases, then y also increases. As x decreases, y also decreases. So you can also name a graph y equals to, what is it, 2 to the x minus 1. Even on the previous question, you can also name your graph y equals to 2 to the x minus 1.